Hey guys, welcome back. So this is the second geometry video, and I want to stop you first and I want to ask and make sure that you have watched the angles and lines video first. If you have not watched the angles and lines video, I need you to stop watching this and go back and watch that one first, because you're introduced to certain terms and certain concepts that you're going to need to understand in order to understand this video and how to categorize and classify different shapes, mainly polygons and quadrilaterals. So let's go ahead and jump in. First of all, let's start off by talking about polygons. So polygons, what are they? Polygons are any shape with these three attributes or characteristics. So number one, polygons are always made up of all straight sides. There's no curves in them. Number two, they have at least three sides that are all closed in. Number three, they are two-dimensional, meaning they can be drawn on a flat surface such as paper. Okay? All right, so polygons are a very large category or group of shapes. Okay, there's many different shapes that belong to that polygon group. Okay, so let's start off by understanding that it is a very large group of shapes that include many different kinds of other shapes that can be broken down into what we can call subcategories or smaller categories. So one of those subcategories that polygons can be broken into is another group of shapes known as quadrilaterals. So quadrilaterals, this notice says it's a parade of four-sided polygons. So basically a quadrilateral is any shape that is made up of four sides. If you look at the word quadrilateral, it has the prefix quad, which actually means four. All right, so quadrilaterals, like I said, there are many different types of quadrilaterals. We identify quadrilaterals using their sides and angles. All quadrilaterals are made of exactly four sides and exactly four angles. So here's an example of a shape that would fall under that category of quadrilaterals. We have 1, 2, 3, 4 sides, and then you have your four angles. Here's angle 1, here's angle 2, here's angle 3, and here's angle 4. So this is a polygon, but as we narrow it down, this is a special polygon known as a quadrilateral because it's made up of exactly four sides and four angles. All right, so let's review a little bit of what we just learned concerning polygons and quadrilaterals, but also what you learned in the previous video about lines and angles. So all polygons are made up of line segments and angles. The line segments that create quadrilaterals will be parallel, perpendicular, or intersecting. So here's some examples. So if you look at this quadrilateral right here, this is a quadrilateral that's made up of four sides, as you can see, in four angles. And the left side and the right side, notice it says the opposite sides of this quadrilateral are parallel. So the left is parallel to the right, and then the top is also parallel to the bottom. Now, if you look at this shape here, this is another example of a polygon that can be categorized as a quadrilateral because, again, it's made of four sides and four shapes. You can see it says the adjacent sides of this quadrilateral are perpendicular. Adjacent meaning that they're like neighbors. They share a corner, basically, or a vertex. All right. So you can see this top side where it meets with this left side, they're perpendicular because this angle that they form here is a right angle. And then finally, we have this guy over here. That's another example of a polygon that's a quadrilateral because it's made up of four sides and four shapes. The adjacent sides of this quadrilateral are intersecting. So the left and the bottom are simply intersecting. They're not perpendicular because they don't form right angles. Okay? So I know that some of you are like, but wait a minute. This shape's called a rectangle, and this is a trapezoid. And you're right. Remember what I said. Polygons is a very big group of shapes that can be broken into subcategories or smaller categories. So these polygons have been broken down into now quadrilaterals. We're talking about quadrilaterals, and we can even take quadrilaterals and break them down into smaller subgroups. All right, so more review. The angles that make up polygons will be right angles, acute angles, or obtuse angles. Now you understand why you need to watch the first video first. So here's some examples. Notice the angles in each shape that are highlighted in white. It says the angle that makes up this vertex of this quadrilateral is acute. So this is an example of an acute angle, less than 90 degrees, remember, meaning closer than 90 degrees. The angle that makes up this vertex of this quadrilateral is right, meaning it's a right angle. So the angle of this square, you can see, makes a right angle. And then finally, over here, we have this white angle here. The angle that makes up the vertex of this quadrilateral is obtuse. Remember, that means here's your 90-degree angle, and it's opened up more. Okay, it's greater than 90 degrees. All right. Now, one thing that I didn't go over in the last video that I want to go over right now, concave angles. So this is not a new type of angle. We're still dealing with right, acute, and obtuse angles. But this is a characteristic of some angles. So some angles are concave. What that means is this. When an angle is concave, the vertex of the angle points towards the inside of the shape. So if you look carefully at this shape, one of the angles is concave because it points towards the inside of the shape. So I just want you to kind of think in your head which one you think it is. If you're thinking this one right here, you are right. So we have a ray here and a ray here forming an angle, but notice the vertex of the angle is pointing towards the inside of the shape. So this is called a concave angle, making this a concave shape. So when you do your math activities for the last week of school, you're going to come across that word concave. So if a shape has at least one angle that's concave that points in, then that is considered a concave shape. All right, the opposite of concave would be convex. So some angles are convex angles. When an angle is convex, the vertex of the angle points away from the shape. This is how most shapes are that you're used to. So here's a hexagon, and if you look, all of the angles on this hexagon are convex, meaning they're pointing out. Okay, the vertex is pointing away from the shape. You can see 6 sides, and you'll notice that whenever you know the number of sides, there's always going to be that many angles. 6 sides meaning 6 angles as well, and they're all convex pointing out. So I want to go back to this one real quick. So this is concave, but notice this is convex, this is convex, this is convex. In order for a shape to be considered a concave shape, all it needs is one angle that's concave. This has no concave angle, so this would be an example of a shape that's convex, all right? One last thing, one trick. To remember the difference between concave and convex, here's a tip. Think about concave. It points on the inside. It points towards the inside of the shape. Well, think of the word cave. If you look at the word concave, you see the word cave here. When you have a cave leads to the inside of like a large rock or a mountain, right? So it's kind of like a cave entrance, isn't it? Okay. So that's one way that you can kind of distinguish the difference between concave and convex. All right, moving on. Rectangles. A rectangle is an example of a quadrilateral because it's made up of 4 sides. A rectangle is a quadrilateral that has 2 pairs of parallel sides that are equal and exactly 4 right angles. So this is the definition of a rectangle. So it's got 2 pairs of parallel sides. Now remember, it takes 2 to make a pair. So the top and the opposite would be the bottom. There's 1 pair of sides that are parallel. And then if you look at the left and the opposite would be the right, those 2 sides are parallel to each other. So that's where we're getting 2 pairs of parallel sides. Notice we didn't say 4 parallel sides. We have 2 pairs of parallel sides, which would be 4 sides. Now notice it also says that they have exactly 4 right angles. So a shape is always considered a rectangle if it's made up of 4 right angles. And you can see all 4 angles on a rectangle are right angles. Okay? Moving on. Squares. A square is a quadrilateral and special type of rectangle that has 4 equal sides and 4 right angles. And yes, you did read that correct. A square is actually a rectangle. I know, at least for my students, I've been telling them that all year long. Whenever we talk about shapes, I always like to throw in those little pieces of information so that way when they're taught later on, they actually So most of them tend to remember that a square is actually a special rectangle because, look, didn't we say a rectangle has two pairs of parallel sides that are equal and exactly 4 right angles? So if you look, this has exactly 2 pairs of parallel sides. The top is parallel to the bottom. The left is parallel to the right, and it's made up of 4 right angles, making this a rectangle. The thing is that a square is a special type of rectangle because it's a rectangle that has 4 equal sides, basically. All right, so that's why it has its own name. It's called a square. So that means all squares are rectangles, but not all rectangles are considered squares. Okay, just stop and think about that, and it'll make sense to you. For example, this is not a square, but it is a rectangle. This one is a square, and it's also a rectangle. All squares are rectangles, but not all rectangles are going to be squares. The rectangle has to have 4 equal sides for it to be a square. All right, I think I skipped this. This square has 4 right angles, and all 4 sides are congruent, which means the same length. How many pairs or sets of parallel sides do you see? And we already talked about that and highlighted. We have 2 pairs of parallel sides. Again, 4 right angles, making this a special rectangle that we call a square. Rhombus. A rhombus is a quadrilateral that has 4 equal sides and 2 pairs of parallel sides. So we have 4 equal sides and 2 pairs of parallel sides. So the left, or depending on how you want to look at it, kind of like the top and bottom here, well, they're on diagonals, but this side and the opposite side are parallel. And then this side and its opposite side, which is the side on the other side across, are parallel. And you'll notice that all 4 sides are the same length. That is what makes this a rhombus. All 4 sides are the same length, and it has 2 pairs of parallel sides. So this rhombus has 4 congruent sides and 2 pairs of parallel sides. Can a square be a rhombus? Think about this. A rhombus has 4 equal sides. Think about a square. And a rhombus has 2 pairs of parallel sides. Think about a square. Can a square, or is a square also a rhombus? If you are saying, oh, I went the wrong way. If you're saying yes, you are correct. Squares have 4 congruent sides and 2 pairs of parallel sides, making them also a rhombus. Okay? Now, some of you are like, wait a minute, that doesn't look like a rhombus to me. Well, if you look at a square and you simply do this with it, now it kind of looks like a rhombus too, doesn't it? So this is kind of like the whole square and rectangle thing. All squares are special rectangles, but not all rectangles are squares. All squares are also a rhombus, but not all rhombuses are going to be squares. This rhombus is a square also because it's made of 4 equal sides and it has 4 right angles. However, this rhombus is not a square because, yes, it has 4 equal sides, but it does not have 4 right angles. This is acute, this is acute, this is obtuse, this is obtuse. Gets tricky. All right, so let's move on. Trapezoids. A trapezoid is a quadrilateral that has 1 pair of parallel sides. So that's what makes a trapezoid a trapezoid. It's a quadrilateral that has exactly 1 pair of parallel sides. So what sides on this are parallel? Is the top parallel to the bottom, or is the left parallel to the right? Hopefully you are saying the top is parallel to the bottom because they are. They are the same distance apart. They will never intersect. The left and the right are not parallel because, I'm just going to draw this out for you real quick. If, remember, lines go on forever and ever in each direction, right? If these were parallel, then they would never intersect even after you extended them. But notice, if you kept going, they eventually intersect. They are not the same distance apart. They're far away down here, and as you go up, they get closer and closer together. So that is why a trapezoid, we're saying, only has 1 pair of parallel sides, okay? So any quadrilateral that has exactly 1 pair of parallel sides is called a trapezoid. Moving on, parallelograms. A parallelogram is another example of a quadrilateral that has exactly two pairs of parallel sides. So, if you look, the top is parallel to the bottom, and the left is parallel to, oh boy, that's ugly, sorry. The left is parallel to the right. So this has exactly two pairs of parallel sides, making it a parallelogram. So guess what? Remember, rectangles also have two pairs of parallel sides, and squares have two pairs of parallel sides. So guess what? Squares and rectangles, they're also an example of parallelograms, okay? So you can see as we start with this large category of shapes known as polygon, and then we break it down into quadrilaterals. Now, our quadrilaterals, sometimes certain shapes are more than one kind of quadrilateral, all right? It all depends on the angles and the sides. All right, so quadrilaterals. With your newly found knowledge, you will be able to identify quadrilaterals everywhere. Try it on these. So just real quick, this is a rectangle, but it's also a parallelogram. Okay, this is a square, but it's also a rectangle, a special rectangle with four equal sides. We also learned that it's a rhombus because it's made up of four equal sides. And we also learned that this is also a parallelogram because it has two pairs of parallel sides. Okay. If we talk about a trapezoid is really only a trapezoid. Okay. Because trapezoids are different from all these because they only have one pair of parallel sides. The top is parallel to the bottom. If you go over here, this is another example of a trapezoid because it only has one pair of parallel sides. This time the left is parallel to the right. The top and the bottom, however, are not, because if this kept going, it's eventually going to go down and intersect with this line, right? All right, so we have a rhombus here, which is a quadrilateral, obviously, made up of four equal sides, but this rhombus is not a square. This square is also a rhombus, but this rhombus is not a square because we have an obtuse angle, acute angle, acute angle. And finally, over here, we have a parallelogram, okay? And that's all we can call this. It's a parallelogram. It's not a rectangle. Don't get tricked. The reason being is because rectangles have four right angles. This has an obtuse angle, and then acute and acute, okay? So if you look at this flow chart, it kind of breaks it down. So the big category of shapes that we're looking at are polygons, but specifically the subcategory of quadrilaterals. And if we break it down, we could go to a parallelogram, and a parallelogram can be broken down into a rectangle and a rhombus. Square, notice, is connected to both rectangle and rhombus because a square is a special rectangle and a square is also a rhombus. Okay? Rhombus and rectangles are parallelograms. That's why they're connected. Okay? And then over here, trapezoids are kind of over here by themselves because a trapezoid is only considered a trapezoid. They are not parallelograms. They're not rhombuses. They're not rectangles. Okay? All right, so it's a lot to take in, guys. Geometry, there's a lot to it. You really have to focus on the sides, the relationships of the sides to each other, and the angles. Hopefully, this will help you when you go to do your work this week.